Good day, and welcome to day 4 of our journeys from learning at home. Today, we are going to look at our third method of apportionment. Now, the past few days, we've looked at Hamilton's method, in which we find the natural quota, we round down, we determine how many seats we currently have, and then we look at the largest fractional parts, the number of seats that we need, we round up that many individuals' natural quotas. Lowndes method, we look at the largest relative fractional part. So once we have the natural quotas, we round down, we find the relative fractional parts, which are the decimal pieces divided by the integer. However many seats we still need, we add that many in order of the largest relative fractional parts. Those two methods are what we call quota methods of apportionment. Quota methods, we take the natural quotas and we adjust those values until we have the correct number of seats allocated. Hamilton's method, we look at the number of the largest fractional part, and we round up that many seats. For the Lowndes method, we look at the largest relative fractional part, and we round up those states that meet the qualifications. Those are our two quota methods. Quota methods, we adjust the natural quotas. Now we're going to start looking at divisor methods. Divisor methods are a little bit more involved in the calculation, but mathematically, keeps the same divisor for every single state. So there is a mathematical reason behind things, as well as a political reason why we choose a specific method. Now, our divisor methods, rather than looking at the natural divisor and modifying that some way, rather than looking at the natural quota and modifying that some way, the divisor methods change the natural divisor. We determine what we're going to call a modified divisor, so that when we find modified quotas and round according to some rule, then we give the correct number of seats. So quota methods, Hamilton and Lowndes, we looked at the natural quotas and we adjusted those. The divisor methods, we come up with a new divisor, and we've got to figure that out along the way. So the first method that we're going to have is Jefferson's method. Jefferson's method was initially proposed by Thomas Jefferson. 1789, when the Continental Congress met, Hamilton proposed his method. It worked out. It was passed through the House of Representatives, passed through the Senate, made its way to George Washington's desk, and he said no. That was the very first presidential veto. So if you're looking for on Jeopardy someday, I could make you some money. Hamilton's method of apportionment was the very first presidential veto in the history of the United States. Instead, Washington went with Jefferson's method. Now, Washington and Jefferson were wealthy white landowners in Virginia, and Jefferson's method politically took one seat away from New York, took one seat away from Pennsylvania, and gave additional seats to Virginia. So politically, it started to favor those southern states. Just the way it worked out, they came up with some numbers, and it happened to help them out, so why not go with it? So Jefferson's method, we're going to start off exactly the same way as we have for our Hamilton's and Lowndes methods. The very first thing, we're going to determine our total population, natural divisors, natural quotas just as before. We round those natural quotas down and determine Jefferson's initial allocation. So exactly the same as Hamilton and Lowndes method. We go through the steps here, and then we're going to do two different examples to see how it works out. After we find our natural quotas and round down, we've got two different possibilities. We might have too few seats, not enough seats being allocated, or we might have too many seats being allocated. In either case, we're going to choose a new, what we call modified divisor. So we're changing it, we pick some new number. Now there is a way to figure out how we want to think about it. If we have not enough seats, then we need to change our divisor so that it is less than whatever was previously used. If we have too many seats, we're going to increase our modified divisor over what was previously used. Think about in division, if you divide by a smaller value, your quotient increases. If you divide by a greater value, your quotient decreases. In this case, our quota increases or our quota decreases. We're trying to get more seats or less seats based upon what we have. Those, in turn, generate our modified quotas. So just like the natural quota gave us the natural divisor gave us the natural quotas, this new modified divisor gives us our new modified quotas. Jefferson's rule says round down. Just truncate the values. We don't care about the decimals, round down no matter what it is. Once that, we figure out how many seeds does the current divisor give us. If it works, great. If it does not work, we repeat those steps and we go through this process of finding a new divisor, either less than or greater than the previously used divisor, finding our natural codes and rounding down every single time until things work out perfectly. So it takes a few steps. Let's see it in action. Next page, I've got different examples. We're going to work through it, see what we have to do. Here, we have an example. We've got Maine's 1790 apportionment. We're going to split up 30 representatives to the state government based upon county populations. Now, rather than doing this in the calculator and adding it together, I'm going to go in and use list operations. It takes and saves us on the computation periodically, so it makes things a little bit more efficient for us. So first thing, we've got our 5 states in this case, or the counties. Find the total population. We need 37 representatives. Find the natural divisor. In the calculator, I'm going to the stat menu, dead center on the calculator. In here, I'm going to go to edit. Now, if we have something already in one of our lists, we can go up, arrow up all the way to the top, hit the clear button, and enter. It will wipe out a list. If by some chance we are missing a list, if we have deleted a list, it's not there, we need to reinstall that. So I'm going to go back to my home screen, to the stat menu once again, and number 5, setup editor, will restore everything. So I'll select setup editor, hit enter, and what that does is when I go stat edit, puts all the lists back into place. In list 1, I'm going to enter the populations that we have. Now, rather than adding these together, not that that's difficult, but I can take advantage of the calculator mechanics to automatically add this for us. I'm in the second mode, the quit button, go back to the home screen. I want to take that list and I want to add everything together. So I'm going to go to the list menu, which is second stat. I'm going to go over to math and down to number 5, sum. This is going to add together a list of elements. Now I want to add all values in list 1. So I'm going to select L1. You notice in blue above the 1 key is L1. So I'm going to hit second L1. Now when I do sum L1, I get the total population in this case. There we go. Put that over, 95, 450. We want the natural divisor next. The natural divisor, we take our sum, we're going to divide by the house size, which in this case, back up top, was 37. There's our natural divisor. Because our numbers are so large, rounding probably don't need the decimals. I'm going to cut it down to just the integer for this case. Let's see what happens. So my natural divisor is 2582. And what we've done before is we've taken the population divided by the natural divisor, taken the next population, and so forth. We can do all of this at once. We go back into the stat menu, into edit, list 2. What I'm going to do in list 2 is I'm going to write a command that allows us to take all of the numbers in list 1 and divide by something. So I'm going to define this. I'm going to arrow all the way up to the top, not in the first space. I'm going to arrow up to the top, highlight L2, hit enter. That gives me a cursor down at the bottom, says L2 equals. We're going to define this as taking list 1 and dividing by our natural divisor. Making this one extra step, we're going to lock this, so I'm going to automatically change things. I'm going to type in alpha by quotation marks first. This locks the list operation so that we continuously can change it over time. Second alpha, and now I want to do list 1, second 1, divided by my natural divisor, which was 2582. We're going to close the quotation marks. So again, alpha plus quotation marks. Hit enter. You can see up top, there's a little lock button. That allows us to constantly change this as we wish. We have now our natural quotas. I'm going to go put those into my sheet. 9.47. Our initial allocation will be those values rounded down. Jefferson always rounds down. So 9.47 gives us 9. 3.67 gives us 3. 11.6 gives us 11. 1.07 gives us 1. 11.16 gives us 11. We have a total, if we add those together, 9 and 3 is 12, 11 is 23, 1 is 24, and 11 is 35. We need 2 more seats. So here, I'm going to make note that 2582 as a divisor gave us 35 seats. We need more seats. We need 37 seats. I'm going to go back up to my notes up top. Now, so that is step 2. If not enough seats are allocated, we're going to choose a new modified divisor that is less than what was previously used. 2582 gave us too few seats, so we need to choose something that is less than 2582. I'm going to try 2400. Let's see what that does for us. Back to the calculator. Now, we could do every single population divided by 2400, see what we get. Again, by using the stat list operation. Now, if I arrow up to where it's L2 is locked, if I hit enter, I get the cursor, I can go and change my divisor here. So instead of 2582, I'm going to use 2400. I am picking a number that is just less than something. You might choose 2500. You might choose 2000. Over time, we'll get better at coming up. It is a guess, and then we'll check and see what happens. So now, I used 2400. Those values are our modified quota. I've put in 4 sets of columns with the quotas and the allocation. Hopefully we'll be able to do this in 4. 2400 gives us 10.2, gives us 3.97, actually 98 if we round that. We have 12.48, 1.15, always rounding down. So even now I'm going to go back to that 3.987 there, 3.98. Doesn't matter how close it was, it is less than 4. We are going to round down. And York, 12.009. Rounding down, we have 10, 3. Always round down, 12, 1, and 12. So we can see that we've added 1 seat, we've added 2 seats, we've added 3 seats. We are up to 38. Adding that, that's 13, 25, 26, 38. So 2400 gave us 38 seats. 2582, our natural divisor, was too low. 2400 gave us 38 seats, was too high. Jefferson's and the rest of the divisor methods are all about finding that Goldilocks zone. This is too low, this is too high. We need something that's in between. So we'll pick some number in between 2582 and 2400. What I like to do is I like to write things in order, make basically a table, and so I can constantly guess and check. 2400 was too little. Well, I'm going to try 2500. Pick something right in between the two. So now I'm going to try 2500. This is going to be our second guess. Back to the calculator. If we were doing this by hand, we would be doing all of this division all again. But now, because we're using the stat list menu, I'm arrowed up to the top where it says L2, hit enter, we can type in, change that divisor. That's the value of locking this with those quotation marks. So I'm going to change that to 2500, See what happens. I'm going to take those numbers. Those are our modified quotas. I'm just going to jump a step and go right to our modified allocation. It's going to get 9, 3, 11, 1, and 11. You notice that 9, 3, 11, 1, 11 is exactly the same that we started with. So 2,500, again, gets us 35 seats. Still too low. We need something in between 2,500 and 2,400. I like to guess exactly halfway, and then by half, either is going to be too low or too less, and we can keep on pinpointing what we have. Do this again, 2,450. Back to the calculator, arrow up to the L2. I'm going to change this to 2,450. I'm going to look at my numbers and adjust. So this time we came up with 9.97. That's so close. Round down gives us 9. 3.89. Round down gives us 3. 12.21 gives us 12. We gained a seat there. 1.12 gets us 1. 11.7 gets us 11. You can see that we gained 1 seat. That gives us 36 now. Almost there. You notice that 2,450 gives us 36 seats. 2,400 gets us 38 seats. It's got to be something in the middle. I'm going to check 2,425. Halfway between those two values. Try this. Hopefully it gets it to us this time. Back to the calculator. Up top. Enter. Change my divisor to 2,425. Ooh, there it is. So I can see. Scroll over there. Modified allocation 4. This time 10.082. Just over 10 gives us 10. 3.93. Almost but not quite gives us 3. 12.35 gets us 12. 1.1 gets us 1. And 11.8 gets us 11. If we add those together, you can see that with the 10, we picked up 1 additional seat, and none of the other ones changed. That's going to give us 37. So 2,425 gave us 37 seats. That's going to be our modified divisor. That's the modified divisor that we want in the end. And down, finally, 4, that gave us our modified allocation that we wanted. That's Jefferson's method. We do have to go through that trial and error, guess and check. For the calculator, what's important is not the numbers for the modified quota at each time, which is why I stopped writing it, but instead those values rounded down and the total number that we have. There we go. That's Jefferson's method. Try it out. Good luck. Let me know if you have any questions.